This is gonna blow your mind. We look up at the night sky filled with a sense of wonder. Since the dawn of humanity, the stars have beckoned. Tonight, we turn our attention to a celestial neighbor that has captured our imaginations for centuries: Mars. This red planet, visible to the naked eye, has inspired countless stories, scientific inquiries, and dreams of one day becoming an interplanetary species. But could humans actually live on Mars? The challenges are enormous, from the thin atmosphere to the lack of liquid water on the surface. Yet the human spirit is one of exploration, of pushing the boundaries of what is possible. Scientists and engineers around the world are working tirelessly to develop the technologies that could one day allow us to live and thrive on Mars. If we can learn to live on Mars, we can overcome almost any obstacle. Mars is not just a scientific curiosity, it is a test of our ingenuity, our determination, and our capacity to innovate. Perhaps that something incredible lies on the surface of Mars, waiting for us to unlock its secrets. Mars, our reddish neighbor, has captivated stargazers for millennia. Today, our fascination has evolved into a scientific endeavor, driven by the tantalizing possibility of establishing a human presence beyond Earth. The journey to Mars, however, is not a simple one. At its closest, Mars is roughly 35 million miles away, a journey of several months even with our most advanced spacecraft. This distance poses significant logistical challenges, from transporting supplies and equipment to ensuring the safety and well-being of the astronauts during the long and arduous voyage. Once we reach Mars, the challenges only intensify. The red planet's thin atmosphere, composed primarily of carbon dioxide, is inhospitable to humans. We would need to develop innovative technologies to create breathable air, perhaps by extracting oxygen from the Martian soil or atmosphere. Despite these obstacles, the scientific community remains optimistic. Survival on any celestial body hinges on two fundamental needs: breathable air and sustenance. On Mars, both pose formidable challenges. The thin Martian atmosphere, composed primarily of carbon dioxide with scant traces of nitrogen and oxygen, is unsuitable for human respiration. This means we would need to create our own oxygen, essentially terraforming small pockets of Mars to mimic Earth's atmosphere. One promising approach involves utilizing Martian resources. Scientists believe that oxygen could be extracted from the Martian soil, which contains iron oxides, through a process called electrolysis. Food production on Mars presents a different set of hurdles. The Martian soil, lacking essential nutrients and organic matter, is unsuitable for traditional agriculture. However, researchers are experimenting with hydroponics and aeroponics, methods of growing plants without soil, utilizing nutrient-rich water solutions and controlled environments. The success of these endeavors hinges on further research and technological advancements. Andy Weir's gripping novel, The Martian, and its subsequent film adaptation, captivated audiences worldwide with its tale of human ingenuity and survival on Mars. While a work of fiction, the story cleverly weaves real-world science into its narrative, offering a glimpse into the potential challenges and solutions for Martian habitation. One of the most memorable aspects of the story is astronaut Mark Watney's resourcefulness in growing potatoes on Martian soil. Scientists are exploring the use of biofertilizers and genetically engineered microorganisms to enhance the fertility of Martian soil, making it suitable for plant growth. Another concept explored in the movie is the utilization of the Martian rover for transportation and exploration. This highlights the importance of robust and versatile rovers in future Martian missions. The Martian also underscores the critical role of communication and problem-solving in space exploration. While The Martian is a fictional account, it serves as a reminder that human ingenuity, coupled with scientific advancements, might hold the key to overcoming the challenges of Martian exploration and habitation. Sheltering from the storm radiation and temperature extremes. Mars presents a hostile environment with extreme temperature fluctuations and high levels of radiation. Unlike Earth, with its protective magnetic field and thick atmosphere, Mars offers little natural shielding from the harsh realities of space. To survive on the red planet, we need to create safe havens, habitats that can withstand these challenges. One of the primary concerns is radiation. Mars lacks a global magnetic field and has a thin atmosphere, which means that the surface is bombarded by harmful radiation from the sun and cosmic rays. Prolonged exposure to such radiation can damage DNA, increasing the risk of cancer and other health issues. Therefore, Martian habitats must be designed with radiation shielding as a top priority. One solution is to construct habitats underground or within Martian caves, utilizing the natural shielding provided by layers of rock and soil. Temperature extremes present another challenge, with Mars being much colder than Earth. Water, the elixir of life on a dry planet. Water is the lifeblood of our planet, essential for all known forms of life. On Mars, however, liquid water is scarce on the surface. The red planet's thin atmosphere and low temperatures mean that any water present exists primarily as ice, locked away in polar ice caps and beneath the surface. Access to water is crucial for any future human presence on Mars, not just for drinking but also for growing food, producing oxygen, and other essential processes. Fortunately, there is evidence to suggest that significant amounts of water ice exist beneath the Martian surface. Extracting this water ice will be a key challenge for future missions. One proposed method involves drilling into the ice deposits and heating the ice to melt it, allowing for extraction and purification. Efficient water recycling systems will also be crucial for any long-term human presence on Mars. Psychological frontiers, the human element of space travel. While technological hurdles often dominate discussions about space exploration, the psychological impact of long-duration space travel on astronauts is equally crucial. A mission to Mars, lasting several years, will push the boundaries of human resilience and adaptability, demanding extensive psychological preparation and support for the crew. Confinement, isolation, and the lack of familiar sensory experiences can take a toll on mental well-being. To mitigate these psychological challenges, space agencies are developing comprehensive training programs that simulate the conditions of space travel. Virtual reality simulations can recreate the sights, sounds, and even smells of Earth, providing astronauts with a sense of normalcy and connection to their home planet. Venturing to Mars is not merely a scientific and technological endeavor. It also presents significant financial and ethical considerations. Developing the necessary technologies, launching missions, and establishing a sustainable human presence on Mars will require massive investments, potentially diverting resources from pressing needs here on Earth. Securing such funding will require international collaboration and a long-term commitment from governments and private space agencies. Ethically, the prospect of sending humans to Mars raises questions about environmental responsibility and planetary protection. Establishing ethical guidelines and international agreements will be crucial to ensure that our exploration of Mars is conducted responsibly and sustainably. While Mars often takes center stage in discussions about human space exploration, our solar system is teeming with other intriguing destinations. From the icy moons of Jupiter and Saturn, potentially harboring vast oceans beneath their frozen surfaces, to the asteroid belt, rich in resources that could fuel future spacefaring endeavors, there is much to explore beyond the red planet. Europa, a moon of Jupiter, is a prime candidate for hosting extraterrestrial life. Scientists believe that a salty, liquid water ocean, potentially larger than all of Earth's oceans combined, exists beneath its icy shell. Enceladus, a moon of Saturn, is another intriguing target, spewing jets of water vapor and organic molecules from its south polar region. Further exploration of these icy moons could revolutionize our understanding of the potential for life beyond Earth. The challenges of space exploration are daunting, but the rewards are immeasurable. Venturing beyond Earth is not just about scientific discovery. It is about pushing the boundaries of human ingenuity, inspiring future generations, and ensuring the long-term survival of our species. The universe is vast and full of wonders, and we have only just begun to scratch the surface of what is out there. We must invest in space exploration, fostering international collaboration, and supporting the development of innovative technologies that will enable us to reach for the stars. Educating and inspiring the next generation of scientists, engineers, and explorers is crucial. Space exploration has the power to unite humanity, transcending political and cultural differences as we work together to explore the cosmos and unlock its secrets. As we gaze upon the red planet, we are filled with a sense of wonder and ambition. Mars, once a distant point of light in the night sky, has transformed into a tangible goal, a symbol of our desire to push beyond the boundaries of Earth and explore the cosmos. The challenges of Martian habitation are significant, from the thin atmosphere and lack of liquid water to the radiation and temperature extremes. Yet, the human spirit of exploration, innovation and resilience knows no bounds. We are developing the technologies, conducting the research, and fostering the international collaborations needed to overcome these obstacles. The journey to Mars will be long and arduous, requiring significant financial investments and ethical considerations. By venturing to Mars, we will not only expand our scientific knowledge, but also inspire future generations, drive technological advancements, and ensure the long-term survival of our species. The red planet beckons, and we are ready to answer the call.